Now today I am going to discuss that is one more this situation, that is moment of inertia of a solid sphere, that is. Okay. Sphere is nothing but in your ball or something. Imagine that. Now it is axis is passing through it. Axis is passing through it. It is nothing but what? Diameter only. And also it is symmetric. Either I can hold it like this or I can hold it like this. Anything. You can hold anything or I can hold it like this. It looks like a what? Symmetric things. Or else I can find it moment of inertia about this axis. It is also what? Now a pin is passing like this and it is coming out. This is also what? Diameter. Either you can find it like this or else you can find it like this. Now that's why I have written moment of inertia of a solid sphere about a diameter. This is case 1. That is okay, fine. Now first, this is because very big derivation it is. Now I will rub it. I think I'll rub it. This is video number 6. Okay. This is your solid sphere. This is your solid sphere. This is the diameter. A, B, this is the diameter. This is the center point of your solid sphere. I will call it as a what? O, I will call it as. And this radius is what? R. I am considering this radius is R. This radius is R. Okay. Now, I am considering a small strip. I am considering here. That is, I am considering the small strip. For the calculation purpose, I am considering. This sphere is at a distance of what? X. Here, if you want, you can call it as a P1. This is what? Q1. Anything you can call it as Q1. And this thickness is what? dx. Using Pythagoras theorem and all that, this distance is there, no? This distance, it becomes what? Square root of r square minus of what? X square. So this becomes r square minus x square, because this square plus this square equal to what? R square. So that this square equal to r square minus of what? X square. Okay, fine. Now, here, m is, what is m here? M is mass of the sphere. Mass of the sphere. Mass of the solid sphere. What is R? R is the radius of the sphere. Radius of the solid sphere. Then volume equal to volume of the sphere. V is what? Volume of the sphere of the solid sphere equal to what? 4 by 3 pi into what? R. Then I will write mass per unit volume equal to mass per unit volume equal to mass per unit volume. That is small m, I will call it as. That is m divided by 4 by 3 pi into what? R. Can I write this one equal to what? 3 by 4, I can write it, into m divided by what? Pi into what? R. This is mass per unit volume. This one you consider in the many places in the previous discussion also. Okay. Next is, I am considering what is the area of the strip equal to? Area of the shaded part. Area of the strip equal to pi into what? Radius square here. Area equal to pi r square. This radius equal to how much? Square root of r square minus x square is that. So that square becomes r square minus of what? X square. Any doubt after this? Next. What is the volume of the strip equal to what? Volume equal to volume of the strip equal to area pi into r square minus x square into what? dx. This is the volume of this. I know this volume, I know that. I know the mass per unit volume. Then I can calculate what is the mass of the strip. What is the mass of the strip? For example, that is, I told you the iron bar and all that I told you. Suppose 20 gram, that is what? 20 gram is that. The length of the rod is what? 5 centimeter. That means mass per unit length. Mass per unit length equal to 20 by 5 equal to what? 4 gram. Of course, you have taken length. Here we have to take volume. That is per centimeter. What is the mass of this? 4 gram. For 3 centimeter, how much it is? 4 3s are what? 12. For 4 centimeter, it is 4 4s are what? 60. That means here this multiplied by what? Length you have to multiply. In the same fashion here, mass of the strip equal to mass of the strip equal to mass per unit length. You know right? It is mass per unit length into mass per unit length. M, that is M. Mass per unit length into volume of the strip. Volume of the strip I write. What is mass per unit length? You know this. This is mass of the strip equal to. This is equal to. This is 3 by 4. 3 by 4 into M divided by what? Pi into what? R. Then we know the volume. We know that. This is the what? Volume. Here I am multiplying this into pi into what? R square minus x square into what? Dx. Of course, this pi is what? Get cancelled. So that mass of the strip equal to mass of the strip equal to what is this? 3m divided by what? 4 r cube. Yes or no? 3 by 4 m r cube into bracket r square minus x square into what? Dx. This is the mass of the strip. Once I know the value of the mass of the strip, I can calculate the moment of inertia of the strip. I can calculate. Next. Now I will drop all these portions. I will drop it. Now, because I am interested in calculating the moment of inertia of the what? This strip about the diameter AB. One more thing, remember AB. This distance is minus r. This distance is what? Plus r. That is useful. That is in the next part. Okay. Next. Mass of the strip, we know that. Now, moment of inertia of the strip I am calculating. Moment of inertia of the strip. Moment of inertia of the strip. Moment of inertia of the strip. Strip of upper part. Upper part. That what I am doing is, it is equal to mass, you know that, 3m divided by 4 r cube. 3 by 4, 3m divided by what? 4 r cube into bracket r square minus of x square into what? D. This is mass. What is the formula for the moment of inertia? I equal to m into distance. Distance square. Distance. Here distance is what you have to take. This is the small strip you consider, no? This part, this is, I told you, r square minus of what? X square. About the diameter AB. Moment of inertia of the strip about axis AB equal to. This distance you have to consider. This distance nothing but what? I told you in the previous diagram. It is r square minus x square. Distance square. Square root, distance square. It becomes what? R square minus of x square. I think it is clear for you that is. It is square root of r square minus x square. Again into square root of r square minus x square. Square root of bracket cancels. That's why I am writing r square minus x square. And one more thing is that, students, I am calculating for this strip. I am calculating, no? So that you have to do 1 by 2. We have to do it 1 by 2. This is the confusion. Because not entire this, I am considering what? This one. That's why I have written here 1 by 2. This becomes 3m divided by 8 into what? R cube. Into bracket r square minus x square whole square into what? Dx. So far you calculate the moment of inertia of only the small strip of the upper portion you calculated. Now I want to calculate moment of inertia of the entire sphere, that is entire sphere. Moment of inertia of entire sphere, solid sphere, entire solid sphere equal to integration minus of r, it is plus of r, I am writing 3m divided by 8 into what? R cube into bracket r square minus x square into what? Dx. I think it is clear for you, that is. But you know one formula, minus x to plus x integration, can I write like this? This is one theorem is that 0 to what? R. For that you have to multiply by what? 2 have to multiply. This is a standard integration. When you studied in the B.Sc also, you studied this one, you studied. Now, this moment of inertia equal to 3m divided by 4r cube. Can I write like this? Why I am writing? Because this 4 and this 2 1 ja, this is what? 4 ja. 3m divided by r. Integration 0 to what? R. This one square it. It is r to the power of 4 plus x to the power of 4 minus 2 r square x square into what? Dx. Okay. This way, moment of inertia equal to 3m divided by 4r cube. This way, integration 0 to r to the power of 4 into what? Dx. Plus integration 0 to r x to the power of 4 into what? Dx. Minus 2 r, okay, 2 r square 0 to what? R x square into what? Dx. Because 2r square is the constant, that is I am taking outside. Now we have to integrate this term. I will integrate. Right? I think it is also not required. Moment of inertia equal to 3m divided by what? R cube. Okay. What is the integration of this? R to the power of 4 into what? X. It is 0 to what? R. So, I think it's clear for you. Integration of dx equal to what? X. Plus integration of this is x to the power of 5 divided by 5. It is 0 to what? R. Next, this one minus 2 of r square x square integration x cube by what? 3. 0 to what? R. Now I will substitute. This I equal to 3m divided by r cube into bracket. Substitute this. This is r to the power of 5 because this one plus of this also r to the power of 5 divided by what? 5 minus of what? Minus 2 of, it is 2 by 3. This 2 by 3. It is r to the power of what? 5. 2 to the 2 by what? 3. R to the power 5. Now simplify. Then again, which is the common factor here? In all these things, the common factor is r to the power of 5 is a common factor. Then I equal to, properly, equal to 3m divided by r cube into r to the power of 5 is the common factor in all cases. Can I write like this? 1 plus 1 by 5 minus 2 by what? 3. This is equal to 3m into what? R square. I left anything, there is 4 something. I left here, I left 4, I left. Okay. This is 3 by 4. It is m r square. Because this is r cube, r to the power 5. It is what? R square. Into 4 I left. LCM is what? 15. This is 15 plus of 3 minus of what? 10. Then 15 plus 3, 18. 18 minus of 10 equal to what? 8. This is equal to 3 by 4 m r square into, how much it is? 8 divided by what? 15. This is the term. Now again simplify this term. This is 3 1 ja, 3 5 ja, 4 1 ja, 4 2 ja. Then moment of inertia equal to 2 by 5 into what? M r square. This is a very big derivation of the moment of inertia of a solid sphere. That also I calculate for what? For the about a diameter I calculated. Okay, I think you understood this. Among all the cases, that is what solid sphere you studied, disk you studied, ring you studied, and rectangular bar you studied. Out of all these things, little bit it is lengthy. There is no tough, but it is a lengthy derivation. This is case 1. Case 2 I am studying. What is case 2? About a tangent. About a tangent. Okay. What is the formula for this? About a diameter? 2 by 5 m r square. Remember this. Now, case 2. About a tangent. Okay. This is your solid sphere. This is your axis. This is the diameter. You can consider like this, or else you consider like this. No problem. Now, about a tangent. This is the tangent I am right. This is the tangent. This distance is what? It is x. Can I apply parallel axis theorem here? Here, these two axes, how they are? Parallel. We know that I x dash equal to I of AB plus of m into what? R square. About the diameter, just now we calculate here, it is equal to AB, it is equal to 2 by 5 m r square plus of what? M r square equal to 7 by 5 into what? M r square. This is the moment of inertia of a solid sphere about a tangent. Either you can draw the tangent here, or else you can draw the tangent here. Now successfully I completed all the cases I completed here. That is, one more part is left. That is what? Law of conservation of angular momentum, and also the illustration of it. Normally the 2-mark question becomes, mention give any one illustration for the law of conservation of what? Angular momentum and all that. For that, again you need the knowledge of the linear momentum and relation between linear momentum and angular momentum you need here. The knowledge of what? Force and torque is required. The knowledge of what? Linear velocity and angular velocity is required for it. Okay. Students, this is the notation for angular momentum. This is the notation for the moment of inertia. This is the notation for the angular velocity. What is the definition of angular momentum is? Movement of momentum, that is movement of momentum is called angular momentum. Angular momentum. Of course, by definition we can't understand. Here I am writing angular momentum equal to momentum equal to angular momentum equal to linear momentum into what? Perpendicular distance. Here all are what? Vector quantity. You have to use the formula C equal to A cross B, like that. You don't have to look much about this. Linear momentum multiplied by what? Perpendicular distance. The notation for the angular momentum, I am writing what? Yeah. Linear momentum equal to, they will write M into what? Or some books they will write P, they will write into what? R. MV into what? R. All are mutually perpendicular, that is X, Y and Z. Suppose a given system is divided into what number of parts? M1, this is M2, this is M3 and is rotating. Distance R1, R2, R3, like that. Now, can I write like this? M1, V1 into what? R plus M2, V2, R2 plus so on Mn, Vn into what? R. This is one thing. And in the, I think probably the first or second video I told you, that is the relation between the linear velocity and angular velocity is V equal to R into what? Omega. This is the relation I am recalling this. Substitute this. L equal to M1 into what is V1? R1 into what? R1 into omega. R1 into R1 into omega. Yes. R1 into omega into what? R1 M2. This is R2 into omega into R2 plus it is Mn into what? Rn into what? Omega into what? I think you are getting one confusion here. Here I have written V1 equal to R1 into omega, V2 equal to I have written R3 into omega, but I have not written omega 1, omega 2, omega 3, I have not written. In the clearly I told you in the video 2 and all that, always in the circular motion, the angular velocity is same for all the particles. Angular. Suppose the particle rotates like this, it is rotates. When it makes, this is particle 1, this is particle 2, this is particle 3. When it makes 1 degree, this particle also rotates 1 degree. When this particle rotates 12 degree, this particle also rotates 12 degree. Angular velocity will remain same everywhere in this case. That's why I have written only R1 omega, R2 omega. So that can I write M1 into what? R1 square of what? Omega plus M2 into what? R2 square into what? Omega plus so on. Similarly, Mn Rn square into what? Omega. This one, can I write omega is the common factor here? I will write later. Summation of M into what? R square. I equal to 1 to N. I am writing into what? Omega. Because omega is same in all the cases. What is M R square? That is moment of inertia. So that L equal to I into what? Omega. This is very important derivation for today's discussion. Next. What is angular momentum? Angular momentum equal to moment of inertia into what? Angular velocity. I told you that is in case of, this is in circular motion. In linear motion, momentum equal to mass into what? Velocity. You know that. So that what is the equivalent term of mass? The equivalent term of mass is what? I. What is the equivalent term of V? The equivalent term of V is what? Omega. The equivalent term of P is what? L. This is called linear momentum and this is called then what? Angular momentum. That is. This is how linear motion and circular motion are like exactly what? They are the same only. That is. Okay. This is this one the relation between what? Angular momentum, moment of inertia and velocity. What is the definition? Moment of momentum is called as what? Angular momentum. Or some books they will write the momentum of a particle about a distance, about a certain distance is also called angular momentum. Please students, from the point of examination, competitive examination, here this is of course you can write it is L bar equal to I into what? Omega bar in the vector form. Moment of inertia is a scalar quantity. Angular velocity is a vector quantity. It is called as axial vectors. Axial vector. Axial vector means it rotates like this. When I rotate now, this tips, it moves in what direction? Upward direction. This is the tip. It moves upward direction. These are called as axial vectors and all. Depending upon whether it rotates anti-clockwise or clockwise, the omega may be positive or omega may be what? Negative. And remember here, any vector quantity multiplied by scalar, it gives another vector quantity. Similarly, momentum is a vector quantity, mass is a scalar quantity, velocity is a vector quantity. This is the vector quantity multiplied by scalar, it gives another vector quantity. So that when you are studying in the B.Sc degree level, UC level, one should know which is vector, which is what, the scalar quantity, how they are related, whether you have to use the dot product or you have to use the what, cross product. That knowledge is what it is required. This is one thing. Next. Now, what is torque? Torque always it produces the rotational effect it produces. Rotational effect. Here, movement of momentum is called as what? Or we can define like this. What is force? How do you define the force? Force is nothing but rate of change of what? Momentum unit. Rate of change of momentum is nothing but force. Can I? Please don't copy it. d by dt of m into what? V. It is a differentiation. But here, take a cricket ball and then throw it. Where the mass is not changes, but velocity of your cricket ball is what? Continuously changes. Then can I write like this? M into d by dt of what? Velocity. Then F equal to m into rate of change of velocity is nothing but what? Acceleration you are writing. This is what? Force. In case of what? In case of linear motion. But in the rotational motion, remember, the force and torque, they are the similar term. The torque is the no, in the rotational motion, the equivalent term is what? Force. In case of what? Linear motion. We know that L equal to R cross P, that is what? L equal to R cross P. We can define like this. Momentum about a distance. Momentum about a distance is called as what? Angular momentum and all that. Moment of momentum. That is okay. Fine. Now, here I want to calculate the torque here. How you calculate the force here? Because I am bringing the similarity between the linear motion and the circular motion. P is what? Momentum. If you differentiate the momentum with respect to time, what are you getting here? Force you are getting. Similarly, to calculate the torque, I am differentiating the angular momentum and differentiating. So that here d by dt of, this is d by dt of L equal to d by dt of, it is R cross P, that is R cross P. Vector symbol you must take it. Rate of change of angular momentum is nothing but what? It is torque. This is torque. Equal to. I am differentiating this term. P I will keep it as it is. P into d by dt of what? R. Then plus of R bar into d by dt of what? P bar I am writing. Here, differentiation of any distance with respect to R is the distance. Differentiation of distance with respect to time, it gives velocity, it gives P bar into what? V bar. P bar into what? V bar. It is into the cross multiplication. That is important. Here also cross multiplication. Plus of R bar. It is what? R bar. Into what is this? D by dt of rate of change of linear momentum. It can I will write once again. D by dt of what? P bar. But or else I can write P bar cross of V bar plus R bar cross of what? F bar. I think you are getting the difficult here. A rate of change of linear momentum. A rate of change of linear momentum is nothing but what it is? Force. Remember students, this is the vector quantity torque. Here cross multiplication is that. What is the difference here? This term I am writing 0 on it. Why I am writing the 0 term is momentum and velocity, that is both are acting in the same direction. So that I cross I think mathematics you studied. Momentum is also along the same direction. Velocity is also along the same direction. I and I. What is I cross I? You don't think that it is into. You cross, it is in a cross product of two factors, you should assume that. So that this quantity is what? 0. It is plus R cross into what? F naught. So that torque equal to R cross F like this. Or else torque equal to R F into what? Sin theta. This is the derivation for the what? Torque here. I think you understood this. Torque equal to R cross F. Now, and also what you define here? Torque equal to what? D by dt of what? Angular momentum. Also you are writing. Okay. Just in the beginning I told you this. Torque equal to, you can write in this fashion also. Torque equal to d by dt of what? L. This also you can write it. Rate of change of what? Angular momentum. Just I told you in the beginning. A rate of change of momentum is nothing but what? Force. There we are taking linear momentum, but here it is what? Angular momentum. Where there you are getting the linear force you are getting, but here rotational force, there is nothing but what? Torque we are getting here. Next is this torque equal to d by dt of what? I into what? Omega. Remember this. I define one more term, torque equal to R cross F. And also we can write what is torque? The rate of change of what? Angular momentum. What is angular momentum? I told you that is L equal to what? I into what? Omega. I told you this. Okay. Next. Now, what this is? Define law of conservation of angular momentum. What this statement says is, when no external torque acts on the system, that means there is no what? Torque is acting. Its angular momentum remains constant. Very good definition. Remains constant. I think in the P.U. second also is different. Same kind of definition you studied. Law of conservation of momentum and all that. What is the definition? When no external torque acts on the system, its angular momentum remains constant or conserved. Okay. What is the meaning of this? No external torque means torque equal to 0. I know the equation. Torque equal to d by dt of what? L equal to d by dt of what? R I into omega. When no external torque means what it is? 0. 0 equal to d by dt of what? N equal to d by dt of what? I into omega. Can I write in this fashion here? D by dt of L equal to 0. What is the meaning of this? The differentiation of any constant quantity equal to what? 0 means this L must be what it is? Constant. L must be what? Constant. Here it means, this is the meaning is what? Here differentiation equal to 0 means L equal to what? Constant. What is L? L equal to what? I into omega. So that I into omega equal to what is this? Constant. That means whether the initial case or final case, at any time you see L equal to constant, I omega equal to constant, that means that is a, can I write L initial equal to L what? Final. Or else I1 omega 1 equal to I2 omega. This is the beauty of what? Law of conservation of angular momentum. That is here. When no external torque acts on the system, its angular momentum remains constant. Similar kind of definition you studied in the B.Sc. and also defined law of conservation of what? Momentum and all that. Yeah, I think you understood this. I know the equation. Torque equal to what? D by dt of what? L. L equal to what here? I told you I into omega. This is equal to what? 0. Equal to d by dt of L equal to d by dt of what? I omega. The differentiation of L equal to 0 means it is nothing but what? That quantity is what? Constant. When L is constant, then I omega is also what? Constant. Now there is one more, that is popular question is there. With using the law of conservation of angular momentum, using law of conservation of angular momentum, give any two illustration, one illustration, two illustration, something they are asking at this illustration. Give any one example and all that. For example, a ballet dancer is there. I think you go through the video and know that. You will get a dancer is there. The dancer will be rotating on the, she is on the dancing on the rotating table and all that. Always the moment that is what dancer starts her dancing now, initially her both legs are stretched like this, and the hands are also stretched and legs are also what? Stretched here. When it is stretched like this now, students, I, what is the formula for I? I equal to m into what? R square. I1 omega 1 equal to I2 into omega 2 equal to what? What? I am discussing this one. Now I am stretching like this. When I am stretching like this, R is what? More. This distance is what? More. When the distance is more, I is also what? More. When I is more, omega is what? Less. For example, product should be constant. Suppose I am taking 20. 20, how I can take here? 1 into 20. 2 into what? 10. 4 into what? 5. 5 into what? 4. What do you understand? As one quantity increases and another quantity becomes what? Decreases and all that. Whenever there is dancer, when she stretched her hands and legs at the time, I is more and omega is what? Less here. This is less. And this is, this is what? I is more and this is what? Less. Gradually she will what? She will do is, she will withdraw both her hands towards her chest like this. When she withdraws both hands towards her chest, then what happens? R is what? Decreases. As R decreases, then I is also what? Decreases. Now, finally, this value is decreases or less. When this is less, this quantity is what? More. When this is more, then the speed at which it rotates now, the angular velocity will be what? Increases. Initial her speed is what? Ballet dancer speed is what? Less. Because her moment of inertia is what? More. Gradually, that is what happens. She will withdraw both her hands towards her chest. The moment of inertia decreases, but her rotation speed is what increases. This is the example for the, that is what ballet dancer for the law of conservation of angular momentum illustration. And another one standard example is that probably you would have known that a person is standing on the springboard in the swimming pool and all that. Before jumping into the water, then both his hands and legs both are curved like this. At the time that what happens, initially I is less, so that he will make many curls he will make in the air before reaching the water. But when approaches the water, then he will stretch both legs and hands. Both he will stretch. At the time I will be more and omega will be what? Less. Exactly a reverse case is when the person jumping into the water pond and all that. You write any one example I will right here, but of course I give one example in the notes for the a person standing on the, that is on the springboard, and he jumps into the water and all that. Okay, students, I completed 100% of your moment of inertia chapter I completed here. Thank you. One and all.